Hello world, I am Rohit and today we'll be doing the Minesweeper project of CS50 AI. In the project we need to write an AI to play Minesweeper. I think most of you are already familiar with the game of Minesweeper, in which it contains a grid of cells. Uh, The cells are either a mine or they are safe cells. If a player clicks on a mine, the player loses. In here we'll be using propositional logic and by using sentence structure defined here. This structure basically means among all these cells only one is a mine. I will be explaining that in details while we do the program. In this project we will be implementing these functions in the sentence class, these 4 functions, and in the Minesweeper AI class these 3 functions. I will be explaining each of these functions as we implement them in the code. Before we get into the actual code, just a small note that we do not support any kind of plagiarism and do not just copy paste the project in your code. I highly recommend trying it out first and then seeing the solution. And if this video helps you, consider putting a like and also comment in the video. Now let us get into the actual code. Here we are in VS Code and I have already downloaded the distribution code provided on the project page. Now let us get started to do the first function. Let us first complete the known_mine function in the class sentence, in which it contains a set of cells of the board cells and the number of mines in the count variable. So let us implement it. Suppose we have a set of cells like ABC that is equal to 3. What it means is all the 3 cells in here are mines. So we need to implement this logic in the code. So let us do it. What we did here is, if the length of the set of the cells is equal to the count of mines, then we can safely return all the cells in the set as known to be mines, and if not, we will return an empty set because we are not sure if all of them are mines. Now let us implement the known safe function, in which it returns the set of all cells in self.cells known to be safe. Suppose a set of 3 cells A, B and C equals 0. What it means is, among the 3 cells none of them are mines and all of them are safe. So we can conclude, if a set equals to 0, then all the cells in the set are safe and not mines. So what we did here is, we checked if the count of the set is equal to 0, that means all the cells in the set are safe. So we have returned this self.cell set, and if the number of mines is not equal to 0, then we are returning an empty set. Now let us do the mark_mine function, which updates the internal knowledge representation given the fact that a cell is known to be a mine. So suppose a set A, B and C equals to 2, that means there are 2 mines among the 3 cells, that can be AB, BC or AC. So if we know for sure that A is a mine, we can safely update the knowledge that among B and C there exists only one mine. So we need to implement this logic in the code. So let us do it. So what we did here is, if the pass cell in the function is in self.cells, which is the set of cells, then we'll remove that cell from the set knowing that it is a mine, and we'll update the count. We'll subtract 1 because we are removing one of the cells from the set, as illustrated by the example here. And if the cell is not in the set, we can simply return none. Now we will implement the markSafe function, which updates the internal knowledge representation given the fact that a cell is known to be safe. So let us implement it. Before we write the code, here is an example that will help us to understand what to implement in the code. So suppose a set of A, B, C and D equal to 2. That means there are 2 mines in the set of 4 cells. Now we know that B is safe. That means among these 3 mines, among these 3 cells A, C and D, there are 2 mines. So let us implement this logic in the code. So what we did here is we are checking if the cell is available in the set of cells, and if it is available, we are removing the cell from the set of cells. And in this case, we do not need to update the count of mines because we know that the past cell is a safe cell, and among the rest we don't know for sure. And if the cell is not in self.cells, then we'll return none. I think we have successfully implemented the class of sentence by implementing these 4 functions. Now let us implement the functions in the Minesweeper AI class. First we'll be doing the add knowledge function, which contains 5 objectives. The first 2 are fairly easy to implement, so let us implement them first. So what we did here is we added the cell to the moves made set. In the objective 2, what we did is we marked the cell as safe by adding it to the markSafe set. Now for objective 3, we need to add a new sentence to the AI knowledge base based on the value of the cell and the count. For this objective, we need to get the neighboring cells of 3x3 grid and then check if the neighboring cells are either mine or safe, and accordingly form a new sentence by calling the sentence class as an object. So let us implement it. First we need to make a set of neighboring cells and get the coordinate of the passed cell in the function. So let us declare a neighbor cell set. Now for checking the surrounding 3x3 grid of the cell, of the given cell, we need to loop through from -1 to +1 of the cell's given coordinates or index number. So let us write the loop. Here Ni and Nj represents the cells around the main cell or the cell in the consideration. Now we'll check if the cell Ni and Nj lie within the boundaries of the board. If the cells are not same, the program will continue to run the other parts of the function. Now we will check if our cell Ni and Nj is a mine, and if it is a mine, we'll decrease the count by 1. Now we'll select the cells Ni and Nj if they are not in the list of safe cells or in this list of mines, known mines. So let us implement it. If ni and nj are not in the safe set or the mine set, what we'll do is we'll add the cell to the neighbor cell set which we have declared just here. So let us add it. We'll be adding the cell as a tuple. Now finally we need to create a sentence which includes the neighboring cells and the count of mines, the updated count of mines. So for it we need to create an object. So what we did here is we checked if the neighbor cell set has any of the cells, and if it has the cells we are appending it to the knowledge self.knowledge list which was already given to us in the class Minesweeper AI, and we are creating an object of the sentence class using the neighboring cells and the count of mines. Now let us implement the objective 4. So in objective 4 we need to mark any additional cells as safe or as mines if it can be concluded based on the AI's knowledge base. So it will be kind of like the previous functions we have implemented in the previous class. I think we need to implement infinite while loop here which will run as long as a deduction is found, a new deduction is found to be exact. And let us read also 5 which says add any new sentences to the AI's knowledge base if they can be inferred from existing knowledge. I think it also requires a infinite while loop, so we might need to implement 4 and 5 together. So let us try to implement it. So for checking if any additional cells are mines or safe, we need to loop through all these cells in all the sentences in our self.knowledge list using a loop. So let us implement it. Now it will be kind of similar to the mark mine function that we have already implemented to check if the cells are mine, if all the cells in the given set are mine. So let us implement using the same logic. Here we need to check if the cell already exists in the marked mine list. If not, we'll mark it in the marked mine list, and we'll change the changed variable value to true, indicating a change, so the loop will be continued. So what we did here is we checked if the length of the set of cells is equal to the number of mines, then all the cells in the set are mines, and we are checking each cell if they are not already in the self.mines set, and adding them to the marked mine set and changing the changed value to true for the loop to continue. Now we'll implement kind of the same logic if the cells are safe. So we can copy and paste it, and we will change some of the elements here like we implemented the previous functions. Here the logic will be if the length of the set is equal to 0, then all the cells in the set are safe. Now we need to implement objective 5 using the same while loop. So objective 5 says that we need to infer new sentences from the AI's existing knowledge base. For it, we need to loop through all the sentences in the self.knowledge list and infer if any new sentences are forming and add them to the self.knowledge list. So let us implement it. Here we are using two for loops to get the sentence from the self.knowledge list, because we are comparing the sentences to one another, and if the sentence 1 and sentence 2 are same, we are ignoring that part. Now we are checking if sentence 1 is subset of sentence 2, which both are sets. Then we will create a new set called new cells and our new count called new count. The new cells and new count involves subtracting the sentence 1 cells from sentence 2 cells in the new cells, and the same pattern in new count. So now if there are new cells, we'll create a new sentence and we'll create an object of the sentence class using the new cells and new count. Now the new sentence, if it is not already present in the self.knowledge list, we'll add the new sentence in the self.knowledge list by appending it. We have also changed the changed variable value to true for the loop to continue. Now I think we have successfully implemented this function, which is called add knowledge, and we have successfully implemented all the objectives. Now let us implement the make save move function, which says it should return a safe cell to choose on the Minesweeper board. The move must be known to be safe and not already a move that has been made. This function may use the knowledge in self.mine, self.saves and self.moves made, but should not modify any of these values. So what we need to check here is if a cell exists in the self.save set, and if it exists in there and not in the self.moves made, then we can return the cell. So let us implement it. So what we did here is we looped through the cells in the safe.self set and also checked if the selected cells in the loop are in the moves made set, and if they are not, then we are returning the cell, and if there exists no save move, we are returning none. Now let us implement our final function, which is make random move, in which it returns a move to make on the Minesweeper board. It should choose randomly among the cells that have not already been chosen and are not known to be mines. So for it we need to make sure that the cells that we are selecting are not safe, and if they are safe, we'll be returning that first. So we'll only make random moves if there are no safe moves available. So we have called the make save move function and checked if it is empty or not, and if it is empty, we'll continue to make a random move. Now we need to create a set for the available cells to make a random move on. Now we need to check every cell on the board to check if they are available for us to make a random move on. For it we'll use a nested loop. Now we'll check if the cell exists in the self.movesMade list or is it a mine. So if it is not in self.moves and not in self.mines, we'll add the cell in the available cell set. Now if any cells exist in the available cell set, we will choose a random cell out of the set. So what we did here is we checked if there are any cells in the available cell set, and if there are, then we will return any random choice among the cells available in the available cell set. I know it is a bit confusing, but you will understand if you see the code, and else we will return none. So there were some bugs in our program in the add knowledge function, specifically in here. So if the cells are safe, we need to check if the sentence.count is equal to 0 or not the sentence.cell. So let us do it. And in here for the for loop, we need to use sentence.cells in the list function, or else it will throw an error. So let us do it also. And finally, in the make random move function, here it will be moves made, not just self.moves but self.moves made. Now I think we have correctly implemented the complete program. Now let us run check 50. As you can see, we have correctly passed all the check 50 test cases and our program is 100% correct. You can go right ahead and submit it. This was Minesweeper from CS50 AI.